All right, calculus, welcome to your notes video for Friday, January 23rd. Whether you're doing this via e-learning or in-house, we're going to begin section 4.3. We will come back to section 4.2 when I see you again. All right, here's what I need you to write down. Again, obviously have a bunch of paper and then have some other paper later. We have the increasing, decreasing test. If f prime of x is greater than 0 on an interval, then f is increasing on that interval. If the derivative is positive on an interval, then f is increasing. All right, and if the derivative is negative on an interval, then f is decreasing on that interval. All right, negative derivative, then if the derivative is negative on an interval, then it's decreasing. Rate of change, if something's going up, it's positive slope. Positive rate of change. If a graph curve is going down, then it's got a negative rate of change. All right, so we have f of x is equal to 3x to the fourth minus 4x cubed minus 12x squared plus 5. So again, it's all about the derivatives relationship with 0. So just like we learned about critical numbers in section 4.1. We take a derivative set equal to 0. Again, critical numbers, critical points, they mean the same thing. So here's the derivative. I set equal to 0. All three of those terms have a 12x in common. So I factor out 12x, leaving me with x squared minus x minus 2. What two numbers multiplied to 2 differ by 1? It's x minus 2x plus 1. Cover-up method tells me 12x is equal to 0. So x is 0. X minus 2 is equal to 0. X is 2. X plus 1 is equal to 0. X is a negative 1. Now, section 4.1, you stop there. You got your three critical numbers, three critical points, and then you stopped. This section, we got to figure out intervals of increase, decrease. So what I do is I go from negative infinity to my first critical number, negative 1. Then I go from my first critical number to my second to my third, and then my third here to infinity. So I have 4 intervals. Now, we did this earlier in the year. I'll review in it. See, in these intervals, we're going to have test numbers. What's a good number to use in between for negative infinity and negative 1? How about negative 2? What's a good number to use from in the interval negative 1 to 0, negative 1/2, 0 to 2, definitely 1, 2 to infinity, how about 3? So it's all about, is the derivative positive or negative? Is the derivative greater than 0 or less than 0? So I have highlighted here, you want to go to your most factored form. All right. So what I'm going to do is I'm going to take negative 2. Again, I don't care about what the actual number is. I just want to know, is it negative or positive? So I have negative 2. If I plug negative 2 and I have a negative times a negative times a negative, which is a negative number. A negative number, if the derivative is negative, that means the interval is decreasing. That's ultimately what I care about. If I plug negative 1/2 in, I have a negative times a positive, which means it's positive. The derivative will be positive on that interval, which means the function is increasing. If I plug 1 in, I have a positive times a positive, which is a negative, so the interval is decreasing. Lastly, if I plug 3 in for x, I have a positive times a positive, which means I have the derivative is positive, which means f of x is increasing on that interval. A lot of times you'll see, it'll alternate. Not always, though. We'll catch a few of those later. All right, so the interval is increasing on negative 1 to 0, union 2 to infinity, and this function is decreasing on the interval negative infinity, negative 1, union 0 to 2, and that's how you write it right here. This would be your answer. Okay, nice. Let's try that again. This one might be a little quicker. 1 raised to the 4th power. That's a interesting one to start with. So you have f of x is equal to 2x to the 3rd plus 3x squared minus 36x. I take the derivative, set it equal to 0. You can factor out the 6. You can get rid of the 6. You can divide. It is a positive. Now, if it was a negative 6, you definitely don't want to get rid of it. All right, because then you're going to get intervals of increase and decrease, opposite. All right, so what multiplies 6 differs by 1, positive 3, negative 2. Cover-up method, x equals negative 3, x is equal to 2. So I have 2 critical numbers. I have 2 critical numbers. I'm going to have 3 intervals. Negative infinity to my first critical number, negative 3. Negative 3 to 2, 2 to infinity. All right, so -4 is a good test number, 0 and 3. All right, so I'm going to plug those numbers in right here. Again, a 6, I can put the 6 on the outside of this positive. It's always a positive 6. So if I plug -4 and I have a negative times a negative, which is a positive, it's increasing. If I plug in 0, I have a positive times a negative, which is a negative, it's decreasing. And if I plug 3 and I have a positive times a positive, which is a positive, it's increasing. So the function is increasing on -infinity, -3, union 2 to infinity, and it's decreasing on -3 to 2. That's why this kind of like table is so helpful. Okay, if the derivative is positive on that interval, it's increasing. If the derivative is negative, it's decreasing. All right, folks, I want you to give this the old college try. Example 3 here. Write that down. F of x is equal to 4, or x to the 4th minus 2x squared plus 3. Give that a try. You're going to take the derivative and set it equal to 0. Do that real quick. Pause it. Do it. Let's see what happens. Okay, so you get that. Then you're going to factor out the 4x that they have in common. Cover-up method is going to give you 4x is equal to 0. Then you're going to have x squared minus 1 is equal to 0. X squared is 1. X is plus or minus 1. All right, so we'll talk about this when I see you again. But your intervals are going to be -infinity, -1, -1 to 0, 0 to 1, and 1 to infinity. Going to have a test number. It's a good test number. How about -2, -1/2, +1/2, +2. So right here would be the place to plug it in. The derivative, is it positive or negative? So if I plug -2 in, I'm going to have a negative times a positive, which is a negative, which means it's decreasing. If I have a plug in a -1/2, I'm going to have a negative times, be careful here if you plug. All right, so that's easy, a negative. If I plug in a -1/2, I'm going to get a quarter minus 1, which is a negative, which is a positive, so it's increasing. I'm going to plug in a +1/2, positive, and then I'm going to have 1/2 squared minus 1, that's a negative. And then lastly, if I plug in 2, I'm going to have a positive times positive, which is positive, so it's increasing. So you're going to write increasing on -1 to 0, union 1 to infinity. Decreasing on -infinity, -1, union 0 to 1. All right. Hopefully you tried that. And folks, time for trig. All right. So I have f of x is equal to sine x plus cosine x. I take the derivative, I get cosine x minus sine x. What are you going to do? I'd move this over. So then it's sine x equals cosine x. So where on the unit circle is sine x equal to cosine x? It's in the pi-4th family. So yes, you do got to know that. That's why I put a yes here. That will be expected of you in college. In the unit circle, on the unit circle, where is sine equal to cosine? Where is x equal to y? In the pi-4th family, sine and cosine are both plus or minus √2/2. It's in the first quadrant, positive, positive. In the third quadrant, negative, negative. That they have the same sign. Pi-4ths, 3 pi-4ths, 5 pi-4ths, 7 pi-4ths. So yes, we'll have to know that. I think I put yes somewhere else as well. Maybe. All right. So, and this is on the unit circle, 0 to 2 pi. So it's going to be 0 to pi-4ths, first critical number, pi-4ths to 5 pi-4ths, 5 pi-4ths to the end, 2 pi. If not, it's just going to go in a certain cycle over and over. Gosh, what's a good test angle for 0 to pi/4? It's really only pi/6. All right, so pi/6. I'm gonna plug pi/6 into my derivative, which I guess you're gonna use that cosine x minus sine x. That's probably the best. Cosine of pi/6 minus sine of pi/6, √3/2 minus 1/2 is positive, so it's increasing. And what's a good one to use for pi/4ths to 5 pi/4ths? Pi. Pi is great because it's on an axis. Cosine of pi minus sine of pi, you got -1 minus 0, which is -1. It's decreasing. And then what's a good one to use for 5 pi/4ths to 2 pi? Right here, 3 pi/2, the y-axis, south. Cosine 3 pi over 2 minus sine 3 pi over 2. 0 minus a negative 1 is 1. It is increasing. So this is increasing on 0 to pi fourths, union 5 pi fourths to 2 pi. It's decreasing on pi fourths to 5 pi fourths. All right. Yeah, so, I mean, the trick is going to be a little bit of a challenge, but we can do it. F of x is equal to cosine squared minus 2 sine x. Now, if you wanted to, cosine squared x, same thing as 1 minus sine squared x. But remember, that'd only be useful if we're trying to factor just that, and we're not. You know, we're taking the derivative of it, so I don't really think we need to do that. Okay, so it's cosine x, all of it squared, so the derivative is 2 cos x, then the derivative of cos x minus 2 cos x. Clean it up a little bit. What do they have in common? They both have negative 2 cosine x factored out. A negative divided by a negative is positive. Sine x plus 1. Sine x plus 1. All right. So cover up method. Negative 2 cosine x is 0. Cosine x is equal to 0. Divide both sides by negative 2. 0 divided by negative 2 is still 0. Where in the unit circle is cosine 0? Cosine is 0 up here and right there. All right, that's for something else. That mark right there. So pi over 2 and 3 pi over 2. Cover up method here. Sine x plus 1 is equal to 0. Sine x is a negative 1. Where in the unit circle is sine x negative 1? Right here. All right. So I've got, and again, starting point is 0, ending point at 2 pi. So no negative infinity to infinity. So I'm going from 0 to my first critical number, pi over 2, my first critical number, to my second one, which I see twice, 3 pi over 2, then 3 pi over 2 to 2 pi. In the interval 0 to 2 pi, pi fourths would be a great one to use, and I'm plugging that back in, again, to my derivative right here. If I plug in pi fourths, negative 2 cosine pi fourths, first off, cosine pi fourths is positive. If you multiply it by negative 2, then it's negative. Sine of pi fourths is positive, and then you add 1 to it, it's even more positive. So a negative times a positive is a negative. Again, I don't care about the actual value. Is it negative or positive? So it's decreasing on that interval. What's a good one to use for pi over 2 to 3 pi over 2? Definitely pi. That's why it's highlighted. Okay, negative 2 cosine pi. Well, cosine pi is a negative 1. Negative 1 times negative 2 is 2. Sine of pi is 0, so 0 plus 1 is 1. 2 times 1 is 2, which is positive. It's increasing. The negative 3 pi over 2 to 2 pi, that one's right here. How about 7 pi fourths? 7 pi fourths. So it's going to be negative 2 cosine 7 pi fourths, and which is just positive. Okay, so a positive times a negative is going to be negative. I could have written that. Sine of a 7 pi fourths is a negative, but it's like a negative point. It's negative root 2 over 2, which is like 0.707 on the negative side. Add 1 to it, it's positive. Okay, so you have a negative times a positive number. That's going to give you a negative. So that function is decreasing on that interval. All right, so it's increasing on pi over 2 to 3 pi over 2, and it's decreasing on 0 to 2 pi over 2, union 3 pi over 2 to 2 pi. Nice. All right, we got, I think, just 2 more examples before little assignment. All right, note for my interval here, x is not allowed to be 0. In fact, x has to be 0. So when I talk about the intervals of increase, decrease, like it's got to be 0 to infinity. All right, 0 to infinity. It's got to be greater than 0. If I take the derivative, I get 2x minus 1 minus 1 over x. Okay, now how am I going to solve this? Again, I'm going to use this to plug numbers in. I'm going to multiply everything by x. That's going to give me 2x squared minus x minus 1, and that can factor. Nice. All right, cover up method, 2x plus 1 is equal to 0. X is negative 1/2. All right, so that's a note because x has to be bigger than 0. And I set x minus 1 equal to 0, and I get x is 1. I have a single critical number, and that's 1. My starting point is 0 to my first critical number, my first critical and only critical number to infinity. What is the test number to use? It's 1/2. Now, you could plug this in anywhere. I could go back to the original derivative, or I can plug it in here. It doesn't matter If I go back to the original as I've shown here, 2 times 1/2 minus 1 minus 1 over 1/2. These would cancel, and I'd be left with a -2. Now, if I plug 1/2 in here, I get a positive times a negative, which is a negative. It's decreasing. If I plug in 2 here, I get 4 minus 1 minus 1/2, which is positive. And if I plug 2 in here, I get a positive times positive, which is, you guessed it, positive. All right, so it's increasing on 1 to infinity and decreasing on 0 to 1. Nice, nice, nice. Again, very, very good video here. Pause it whenever. These notes would be very helpful. Finally, f of x is equal to x plus 2 sine x on the interval 0 to 2 pi. What we're going to do here is we're going to take the derivative. We're going to set it equal to 0. I think we have visitors here. All right, so I'm going to get 1 plus 2 cosine x. I'm gonna move the 1 over, and now it's not the time to be a kitty cat.
I'm a kitty cat.
This is not gonna get edited out. Go back upstairs. We're gonna divide by 2. Cosine x is equal to a -1/2. That's it. Where on the unit circle is cosine -1/2? If you cos inverse 1/2, you're going to get 6 degrees. That's pi force family. All right, so, and it's negative here and here. This video is going to end sooner than we thought. Pi thirds to 4 pi thirds. All right, you can do that. 2 pi thirds. I'm sorry, 2 pi thirds and 4 pi thirds. All right, and then there we go. 0 to 2 thirds pi, 2 thirds pi to 4 thirds pi, 4 thirds pi to 2 pi. Good test numbers there. All right, don't say anything inappropriate, Annie. You're live. All right, we'll finish that later. All right, this is an e-learning assignment if you're not in school, right? Not if you're doing a senior skip day, it doesn't count. If you're not in the school. If you are in school, then this is due at the end of the hour. All right, let's go. So you're going to write these down. You're going to turn it into the top tray. You're going to write this down on a separate sheet of paper no matter what. You're going to find the first and second derivative. F of x is 3x squared minus 1 over x. Again, 3x squared minus x to the negative first. Look at this first derivative here, 1 over u. And then what is that going to become? And that is great. And that's also negative tangent x. That's first derivative. Then you take second derivative, easy peasy. Write these all down. Number 3. And he is losing brownie points. Bring down the power, 1 power less. Derivative of that, clean it up, then take the derivative again. You can do it. Sine squared minus cosine squared. Okay? That's really nothing special. I mean, you could rewrite cosine squared as 1 minus sine squared, make everything in terms of sine if you wanted to, or the same thing with cosine, but this could be interesting, huh? 2 sine, the derivative of sine, minus 2 cosine, the derivative. All right, so that's going to be, this is going to be 4 sine x cosine x as the first derivative. Remember, 2 sine x cosine x is equal to sine 2x. So this would be 2 of them. All right, that'll be the first, and then that's the easy second derivative. Nice. Then this one, the derivative of any u is e to the u, and then the derivative of that exponent, and then we clean it up, and then you do it again, and that's going to be the product rule, and that's no big deal, but that's number 5. Write all these down. Annie, do you want to say goodbye?
What?
You want to say bye?
Bye.
Bye. Say, this is Yak Math Video signing out. Do you like math?
Yeah.
Is Dad your favorite?
Yeah.
Oh, that's a good answer. All right, this is Yak Math Videos signing out.